Recording. Recording has started. All right, so Assalamu alaikum everyone. Today is our session number 3 of fundamentals of AI. Um, Today's quote is, future belongs to those who prepare for it today. So we have to work for our future starting today, so that we will have a prosperous future. It depends on you how you put the definition of prosperity. Let's move on. So today's outline, we're gonna go a little bit deep dive into machine learning. We're gonna try to get the um, learn about the machine learning, its types, its differences, different types like supervised, unsupervised, reinforced. What are those learning types? What algorithms we're going to be using, what are some examples. I have quite a lot of examples for you guys, just to give you, some clear understanding where it could be used in our daily life or in our business life or in the academic, however, you put it in. Along with that, we're gonna look into the basic concepts of some of the algorithms. What is regression? What is classification? And there are a couple more as well. We're going to discuss the importance of data in machine learning. We discussed about data in our previous session. What was data? What is a data set? What is algorithm? What is AI algorithm? So we did cover those fundamentals in our previous session. So building a story on top of it. So we're gonna look into the importance of data there, and then what is MLOps? We did look into it last week as well. So we'll just go a little bit deeper in that area as well. Okay. So I'm gonna pause here for any questions that you guys may have for our last week's session. Anything that you want me to clarify or anything they want me to, reiterate on. Right? If no question, then let's move on. Next slide. This is the slide which you are seeing pretty much every session, the difference between artificial intelligence versus machine learning versus deep learning, right? So we're going to be going deeper into the machine learning, which is a subset of AI that uses statistical methods to enable machines to improve with experience. If you have statistics background, if you have maths background, this is going to be a very helpful proposition for you to transition into the machine learning. It is because the underlying principle, it is using underlying, all those algorithms. Pretty much everything is a statistical basis, like regression is one of them, and there are, several other which we're going to be discovering down the road. Understanding, this is the slide, we discussed already, last week. So I'm gonna skip on it. Applications, we did look into, these are some of the subsets of the applications. There are, however, quite a lot other than, these 6, 7, 8, or 10. There are, tons and tons of, applications out there. The opportunities are endless. Say, you find some problem statement at your work and you wanted to optimize on it, or you wanted to see if you can, implement some sort of, machine learning algorithm to automate stuff for you. That would be a better proposition. So try to identify, problem. Say any problem where it takes you guys, let's say, a couple of hours or days or weeks, and a lot of man hours and a lot of resources are required. So try to look into the aspect, how can I or how can we introduce machine learning capability to make our lives easier and transfer the load onto onto the machine to do the heavy lifting for us, so that we could spend our time more on some productive areas. Okay. ML process we did discuss last week, if I am not mistaken, and ML ops as well, we discuss on it. Okay, so here today we're gonna be looking into this hierarchy diagram that you are seeing. You see the machine learning on top, and then underneath it you see different types. You are seeing four different types of machine learning here. Excuse me. First one on the left, you are seeing supervised learning. Second one is the unsupervised learning, and then reinforced learning. So these are, three very common types. And then, semi-supervised, it's a hybrid among the supervised and the unsupervised learning. So here you are seeing, three common ones. So um, you can pick any of the specific area. Say, you want to find your niche, just pick yourself. Let's say, I wanted to go deep dive into the supervised learning. I don't want to do anything else other than, the supervised learning. And I want to learn what are those algorithms used for, what are, some of the use cases and, whatever and whatnot. So, you can deep dive, in that specific area, or if you want to spread your knowledge across the board, be a jack of all instead of master of one. I have an understanding of all the learning types, be supervised, unsupervised, reinforced, or anything in between. So supervised, so these are the come on. These are different learning types, and these are the algorithms that are being used to realize identify the results of that specific learning type. Say on under the supervised learning, say you pick the the regression algorithm for the continuous target variable. What are those? What is the continuous target, and what are the categorical or categorized? We're gonna go see it in our subsequent slides as well. So here you see that supervised learning, since it has two um, two clear demarcations lines. One is the regression, one is the classification, and underneath it, you are seeing different examples as well. Um, so some of the common examples of these types are, one second. Yeah, of these types are under the supervised learning. You have under the regression, we see the house pricing prediction. Say in your neighborhood or in your city, you want to predict the house prices. You can use this. Um, the the very common the platforms for housing pricing platforms, or the house listing platforms like Zillow.com or Realtor.com, or it could be it could be any in your area, maybe like in Pakistan, they have Zameen.com. So utilizing the capability, of the supervised learning, they get to predict the house prices in any specific, neighborhood or specific city. Like, and you can tell if the house prices are, going up, going down, or they are, going steady. So that's one example of it. In the next one, which is the classification type, is the medical imaging. And then, there are a couple other like text classification, or, lane finding on GPS, or driverless cars, is very common example of the reinforced learning. Um, like in Tesla, they call it, the capability is called FSD, which is full self-drive. So, that's a driverless car. A driver is sitting in the car, but he or she is not controlling the car, but, having, utilizing, that capability of machine learning to take you from one point to another, and, take you, to your destination. So that's, some of the examples in here. Let's go deep dive into it. And what is a supervised learning? Uh, Supervised learning is a type of machine learning in which algorithms are trained using labeled data. Do you guys remember last week we discussed about two things? One was label, which was the output, and there was another one which was feature, which was the input. So there were two terminologies we learned, if you remember last week, feature and label. So feature is the input type. Remember, the columns in our Excel sheet, those are the features, or those are the input through which we can, label, or we can, come up to a conclusion or come up to an output. So in the supervised learning, our algorithms, they are trained using the label data, which is data that has a known outcome, uh, and it is used to make the prediction or the classification on the new data. So whatever is coming out, whatever the outcome is, it helps out based on those labels. The what is the prediction. Some of the examples of this definition are here. So these examples are, there's one example in our daily life, which is email spam filters. You know that, you like in your office or work email, say Outlook, or your Gmail, your Hotmail account or Yahoo account, or whatever your email is. So based on the pattern it sees, it quantifies some emails to go into the spam folder or the junk folder, that like they do not make it to your inbox. So there are, certain criteria that, mail provider has put in, and based on those criteria, it makes a prediction or classify that specific email, that if it is going to go into the spam folder, or it is it is going to land into your inbox. Another example uh, is the academia or your academic system, your school or your college, automatic grading system, that actually labels the data, graded the assignments, and based on the feedback and whatever the assessment we put in there, it provides the grade to the student. Um, the next definition is, for going furthermore here, is it involves dividing the available data into training set and the testing set. So as an for example, let's say you have let's say 1 million records. So we do not feed in all those 1 million records into the ML system to to train it. So how it goes is, normally 70% or 50% of the data we like we split the data, let's say, the 50-50. So 50% of the data goes in for the training and testing, that, whatever the ML algorithm, we came up with, based on our judgment and based on our experience, or the system experience, or system, gave it to us. So 50% of the data, we're gonna put it into put it in for the testing and training of the algorithm. So algorithm gets trained on the 50% of it, and then remaining 50% out of which, say, we split, let's say, additional 50-50, we set aside for like 50, or the remaining 50% set aside for testing, and then the other one is for the production use or the prediction uses, that once we feel that our algorithm has gone up to a point that it has addresses the confusion matrix, the precision, and the confidence level. Uh, I'm hoping that these terminologies are making sense to you. If you recall what we discussed last week, we discussed the prediction, we discussed the confusion matrix. Remember, 2 by 2, true positive, or true false, or false positive, or false negatives. Remember those, and then based off of those, we came up with what is the confidence level, and what is the precision of our system. Confidence level, 95% or above, for a let's say, for a healthcare system, or a financial system, we need some higher level of, confidence level. Confidence means like systems confidence that, this specific classification that it came up with, or a specific prediction it came up with, it is, up to like system is say 95% sure that, this is the thing. You remember the example of a mouse, say that it was able to identify it is a mouse, not a pen or not a phone. And that example, if you recall. So based off of that, um, we come up with, with those. So let's say, we have 1 million records. We split those into half. 50% we use for our, the trading set. And then, remaining, 50% out of which, we chunk it out again with, half and half, one half for the testing, and the other half for the, for the prediction. So that, why we do this? Because, this 50% of the data that is, going to use for the training, it is not necessary, or it is not mandatory that we fed that into the system, and turned out that system is turning out the result what we are looking for. The confidence level, the precision level, addressing the other concerns as well. So at times, you fed into it, you find out that it is not up to that par. You tweak your algorithm, you tweak your methodologies, underneath, under the hood, and then uh, train that again and again, up to a point where we reach that goal. And you know then we pick a new set of data, which is this remaining 25% over here. We use that for the testing, and then once the tests come out positive, or come up to a point that this is what we were looking for, then we're gonna move on to make the prediction, make predictions, um, that we're gonna be using this remaining piece here to make the prediction. Make the predictions means that it is going into the production. It is ready to start serving us. Okay, some of the examples are here. You see the financial industry example, and example are the credit scoring, or the personalized advertisement. Personalized advertisement, that uses the label data. As an example, say I'm on YouTube. So if I watching, some specific theme, let's say if I'm watching um, cartoons, or if I'm watching politics, if I'm watching technology, or whatever the theme I'm watching, so the algorithm will keep on showing me some similar things of the interest. So that is, like, it labeled it, hey, what Faisal is interested more into, this specific theme. So let's just start feeding him, keep on feeding him that is specific, or a TikTok example, or a, YouTube short example, that you keep on flipping, for a couple of seconds or a minute or so. You watch that specific short or specific TikTok, you flip it, the next one will be around the similar theme. So um, do this exercise. If you are on TikTok, maybe just sign out from that account, create a fresh account. So once you create the fresh account, it will feed you pretty much everything all over it. It will feed you, the kids stuff. It will feed you, tech stuff, or whatever and whatnot, different types. Then it will that is the time where it starts learning. The algorithm starts learning about my preferences. There will be some videos or some TikToks I'm gonna be watching, like I am showing interest, like I'm watching end to end, or some I'm just, hey, I see the picture, I see the face, or I see some theme there, I'm not interested, I'll just skip that. So this is what system learns, the machine learning behind it. It learns that, hey, what, this is Faisal's preference, that he skips some area, and he is interested in some area where he is watching end to end. So I'm going to start feeding him more in that area. And then as the or as the time progresses, that as we are watching, the system actually learns, from our, preferences as well, and it actually, start building, something concrete. So, it uses us as a test bed, which is the testing set. So we are providing a testing set to the system, so the system will, update itself and, start feeding us something, legit on that area. I hope this example makes sense. All right, so next one is supervised learning. It has, although it has more, but there are two major demarcation lines. One is the regression. Second one is the classification. You see that here. Regression is a type of prediction using a numerical value. It could be, some specific numerical value. Let's say on a scale of 0 to 10, how do I rate it? Or something, that has numbers associated with it, that is the regression algorithm. If you remember, I don't know if any of us, of a statistics or the maths background, or maybe, if you studied engineering, so remember, the X and Y plot, and there is a, diagram, XY diagram, and I'm going to come to that diagram in a bit as well in our next, coming slides. So, there is a X is an independent variable, Y is a dependent variable, Y is dependent on X, whatever the value of X, that on that specific, let's say, on the plotted chart, value of X defines the value of Y. And, as we proceed along, it provides, the input, and, there are some outliers, and there are some, which are um, uh, some areas, which are, along the line, and there are some, like, beyond the line, going up or down, so based on that, we can, plot whatever, data was given to us. So this is an example of, the regression. Now the classification is the predicting a category, classify something, classify it. It is a technology piece, or classified it is a plastic piece, or it is a mouse that is used, in a technology. Classify it as as a pen, not a mouse. So classification of, let's say, you have um, you know uh, a whole lot of, let's say, uh, I'll come to that, from the example side, so classification is, to classify that, this is a specific classification of that object that is, being fed to me, and, this is what I am predicting it as, or categorize it. So, there are, examples related to it here as well. Next bullet is about the success factor or success of a supervised learning. It depends on the quantity and quality of labeled data used for the training. Quantity, as we mentioned, it's not a hard and fast rule to go with 50-50 split on your data set. It could be 70-30, it could be, maybe 10-90 or whatever, right? So the more data we feed into the system, the more it learns and the more precise prediction it is going to provide to us. Say we have 1 million records, out of which, let's say, if we feed into 700,000, it is going to give us a better predicted result than compared to if we feed in, let's say, only 100,000, or the, or the 10% of it. So the more percentage, but there is no silver bullet. There's no hard and fast rule. Maybe, my business, we want to feed in, let's say, 30% of it. We want to keep the remaining 70%, for the additional testing, and, the additional prediction, and, optimization on my on the algorithms. So, we'll just, initially, just for the training side, we're going to use only, let's say, 30% of it. So it depends on the quantity, and also the quality, how better quality the data set is, how better the data set is, the more attributes it has, the more meaningful data it contains, the more better or the better, prediction or the better algorithm, we're going to come up with. The last one is about the some of the common algorithms that are used for the supervised learning. Um, Linear regression is one example. This is the example which I told you about, the XY plot, y-axis and x-axis, and there are some, outliers out there. So the XY plot, that's the linear regression. Then logistic regression. This is um, based off of 0 and 1, either yes or no, or the value is either 0 or 1, or the binary. That's where this regression type is used. A decision tree, let's say you have a decision. A very common example of decision, Ammi comes in every morning, आज क्या पकाना है? And then you start talking to her, अच्छा आज आलू गोश्त हो जाए. अच्छा तो आलू गोश्त के लिए फिर do we have आलू at home? Do we have गोश्त at home? आज घर में गैस आ रही है. All these. So, based on that, the decision, like one thing leads into another, and then, it leads into, further additional decisions. And then, you keep going and going up to you come up to the final decision point. Some additional examples. Here you see the voice recognition system. They are, they use the labeled speech data to recognize and, transcribe the spoken words accurately. Here's the example. Let me find. So, remember there was subtitles here that I was able to, start the subtitles here. So this is the voice recognition system that's inbuilt into PowerPoint by Microsoft, right? So whatever I am speaking, you are seeing at the bottom of the screen. So this is the voice recognition system. The more I speak to it, the more it will learn. So these systems, they are not closed systems. So they have the learning capability. They learn, and then they optimize on. It will learn my accent, and how better I train it, right? So every ethnicity, they have certain accent. So based on that accent, it actually grows itself and comes up with some better um, some better predictive results out there for us. Another example is predicting academic performance. Say we are in the mid of a semester, and that's where we find out that or a professor wanted to identify if this specific student is or he or she going to say be able to pass the exam, or be able to get a 3.0 GPA, or be able to perform well based on the attendance and the study time they are putting in, or how they were doing in the quizzes, and so based on certain the feature set that we are feed into the algorithm, into the algorithm, it will come up with with those predictions for us. Enough on the supervised learning. I'm going to move on to the unsupervised side. Unsupervised learning is, let's just put it as supervised is that it is supervised learning is the one that actually has given some label set. Based off of that, like there is some supervision provided to it, provided to the algorithm, supervision provided by us. On the unsupervised side, there's no there's no label data, given to it. So it is more of unsupervised, going on your own based on the feature set. So this is the feature set fed into it. Now make some decision based off of those algorithms that what could be a predicted result, for that. So unsupervised data without any label output. So we are not providing any labels to it. Unsupervised learning, tries to, it actually tries to group the, the similar data points, together. That they are clustered together, with this, specific area. common examples, are, the anomaly detection, or the clustering, and we'll come to it in a bit, what is clustering and what is, the anomaly detection. Financial systems, we have anomaly detection that say in the audit report, identify some anomaly. Anomaly is something that is out of an ordinary. Say this is the path we have to follow, and something is going beyond that path. So this is an anomaly. Anomaly is like, you are not following the path, you are going in a different direction, or you are deviating from the path. So, the financial systems, as an example, or the audit system, there's let's say, the audit report of an organization. They want to identify, if there is a fraud, or detecting a fraud, in that report, as an example. Um, and then the clustering example is the market segmentation. It can be used to group the customers, on their certain specific behavior, or the demographics, or specific requirements, specific age group. So marketing, that uses it, for their informed decision, or the predicted answers for, let's say, for a specific product, to be put into the shelf, or maybe open a certain mall in that specific area. So, based on their on the customer preferences, their age group, and there are certain areas we can fill in as a feature set. It is often used to explore and understand large and complex data sets to find the pattern that might be obvious otherwise. Say you have a million record, or 10 million records, or 100 million records. Now, if let's say if you feed this into someone, let's say a person, or maybe a team of, let's say, 10 people, they may take days or weeks or months to come up with some, and there is always a chance that those humans, they may make mistake, they may get deviated, they may doze out or whatever, right? So they may or may not come up to the solution what the company is looking for. So that's where, unsupervised learning comes into the picture, review it, and then, get back to us. Hey, this is what it is. And one more example, of going back again, to uh, YouTube and, TikTok. There are, millions and millions of, records out there, and, all those records, all those shorts and the videos, or the TikToks, they are, tens and hundreds of millions in quantity, right? So out of which, to quantify that, what Faisal's preference is, or what Faisal's preference is getting built up, and start feeding that specific area, to me, this is a very complex algorithm, that's very the large and the complex data sets, because there's a huge um, um, set of videos out there, or shorts out there. Now, what needs to be you know assigned to me. Say if I am sitting, let's say, with my kids, and we both are watching on two different devices, you will see that although let's say both the devices have my login, what I am watching, the other device may not be showing the similar thing, because the other device, although it has my login, but if it is used by, let's say, my parent, or my kids, based off of their preference, they may be skipping something, they may be spending more time on one specific area. So those preferences, they are being built as we proceed along. So that's another example of the unsupervised learning. I see there is a hand raised. Yes, Anna, go ahead. Sana, do you have a question? Yeah. All right. Let's move on. Last bullet point, unsupervised learning can be combined with supervised learning. So it's a hybrid one, or it's a semi-supervised, right? So semi-supervised, it's a combination of unsupervised and supervised learning. And it could be a combination of classification and clustering, and combine that together, and come up with something which is more legible. Example, unsupervised learning, can be combined to improve the accuracy and the efficiency. Like we have some set of data that has labels on it, but some is like completely unlabeled, right? So we are going to use that for that specific purpose. So we are going to uh, embed in two different algorithm types, uh, marry them together to come up with something efficient, algorithm for us. Okay. And these are some additional examples. I'm not gonna drain the slide, going into some additional examples here. We will be seeing more and more examples. Give us in our coming slides. There is a third type, um, which is reinforced learning. So reinforced learning is entirely different than your supervised and unsupervised. Reinforced learning is a type that actually uses rewards or penalties. So it has a concept of jaza and saza. Azab or sawab का concept है इसके अंदर. It's a type where the agent or the algorithm, let's put it this way, it learns to make decisions by interacting with an environment. Like based on Faisal's preferences, YouTube is sending something of my specific needs, or autonomous vehicles is another example, where agent can learn to drive a car by practicing or simulating and adjusting its behavior, based on the feedback about its performance. Um, Say, if I'm going from one point to another point, um, Teslas, they have the capability in their full snap drive, or the autonomous drive. If I So it actually learns my daily driving preferences. So in the morning, if I go and drop my kids to the school, and then I take and then after that I come back home, go to work, return, or at work, during the lunchtime I go to a specific mall, um, or a specific place to eat, return back, then in the evening return back home. So if this is my daily routine, so it starts learning, and then if I go with the autonomous capability, it would know that say in the morning, when it's rainy, I try to avoid, let's say, in a specific area, or if it is foggy, I try to uh, instead of going on a regular speed, I lower down my speed to avoid any accident or anything. So these are some of the patterns it learns from me, my driving habits. Plus, it learns from the external agents or external factors as well. If there is something, um, it something it senses, say during Mondays and Wednesdays, the traffic toward my work, the traffic is crazy, but on Thursdays, the traffic is pretty calm. So it learns that, the start of the week, the traffic, is, it's in the, um, like, it is, very much into the frenzy side, and at the tail end of the week, it is going, pretty smooth, or, there's not much of a traffic. So, these are the things, that it actually learns as we know, as we practice more and more. So, and then based on that, it actually adjusts its performance, and like getting those feedbacks, it adjusts itself as well. Next one is uh, it can learn to make decisions by trial and error. um, you know, as we just mentioned about. Another example is, personalized, fitness training. Stock trading is another example of it as well. Um, Voice assistants are, very common examples. Okay, Google or Alexa, of whatever and whatnot, if you have, those devices or, at your home, or maybe, those capabilities on your smartphones, right? So uh, you can use that as well as an example. Uh, Reinforced learning, used to optimize a wide range of decision-making process from, simple to complex, so it could be a simple decision that, should I stop 0.1 second at the stop sign or at the green light, just to make sure that there is no one coming in the other direction or the cross direction. That's one of the simple decision to a complex decision. Hey, today is a rainy day. Should we take that route or not? Or things of that nature. It becomes it can learn by combining with other types of machine learning, as we mentioned. The reinforced learning as well can be now married in, can be merged in with the other types like supervised or unsupervised. It could be into the flow. It could be a merger of all three or maybe one or two for better performance. And the last one become increasingly important in the areas like self-driving cars. Reinforced learning is very common there. Robotics and gaming, and some other examples as well. All right, this is a busy slide. It looks busy, but we're gonna start from the left, and then we're gonna go into the right, or maybe. Okay, let's start from the right hand side. Machine learning, three different types, common types, and then there is a fourth one, which is the hybrid or merge or whatever you call it. Supervised, unsupervised, reinforced, right? Supervised, we have a label set for the output. Unsupervised, nothing's there. We have a feature set. We ask machine to make a decision based on that. Reinforced, um, no concept of labels of features or anything, but it just it learns as it proceeds along, and it has a concept of jazar saza or rewards or penalties. So it rewards itself or penalize itself based off of the decision it made. Supervised has two common types: classification and regression. Regression, as we mentioned, as we discussed, the the algorithm try to result us in a number. It could be 0 to 1, or or 0 or 1, or maybe 0 to 100 or whatever. When there's a number associated, we're going to use the regression. Where there's a classification required, classify this as a mouse, not as a pen, or classify this as a mouse, not as a pen, or vice versa. That's the classification. Like you have the image given, or you have certain specific field given, and give it a classification. Clustering, cluster is I will come to it in a bit. And then the decision making. So mainly reinforce of the reinforced learning of the ML. It is a decision making a, of machine learning. At the bottom here, you are seeing, and I'm not gonna drain these. This is fundamental, so you don't have to go into the details. But the more you learn, the more you know about them, the better it is, or helpful it will be, for you guys, down the road. So these are the algorithms. See, um, decision tree, you see the support vector, you see the random forest, you see the KNN. And then on the regression side, the linear regression or neural regression, and a couple other. And then on the clustering side, you have some examples here, the k-mean clustering, or the Gaussian mixture and all that. And then for the reinforced learning, Q learning, R learning, TD learning, there are some examples. If you are interested, text me, ping me, email me. I know a couple of YouTube channels, and these guys have done a great job for people like those who have, let's say, I studied statistics in my college days, or say, I did some math back in the college days. After that, I am rusty. I don't have any. I have something in my mind, like, mean, median, mode. What are those? What is the purpose of those? But don't know, don't have, much details around those. So those YouTube channels, they will help you out. Not just only build the, like, brush up your skills on the statistics, but how do we, use those, say, the guy will pick, linear regression or multipol or the polynomial regression, and how do we pick it and put it into that specific example. The person goes by the example and try to put it, and these channels are specific to AI and machine learning. So if you are interested, let me know. Maybe I'll just in my next email, I'm gonna just put the name of those YouTube channels, so in your free time you can look into those. All right, so coming to the left-hand side, you see that, these two, regression and classification, they are the type of supervised learning. And then clustering is a type of unsupervised learning. So regression, as I mentioned about the example, the XY plot, you have the plotting, X value of Y dependent on value of X, here's the example is, the over number of experience, as we gain experience year by year, we our salary increases. That's one example. It's not um it's one of the classical examples. It's not necessary that over a period of time, I'm gonna be having my salary increase and all that. Anyways, that's one example of it. Second one on top, you see the classification. Classification example is, credit card fraud detection or the spam filter. Spam filter I mentioned about, right? We discussed in detail that example. Credit card fraud detection. And I have been burned by this a lot of times, a lot of times. Back in the days, pre-pandemic, I used to travel a lot, domestic, and I did at one point in time, I did fill a gas in Chicago. Um, got dropped down at the airport, went to San Diego. I tried to use my credit card there. It just declined. It declined second time. And then I received a text message. Sometimes I receive a phone call from my credit card company. Hey, we see that, a couple of hours ago, you use your credit card in your hometown. You are, somebody is using is that you or is there someone else? Or is your card stolen? So, those, fraud detection systems, so they actually, burned me down, but, it was for my, to help me out. So yeah, that's another example. So it actually classify, like EV classify. Here in US, we do not have much classification examples here. Like we have, normal kachra and the recycle bin, right? So they both are of the same size. We just, throw the stuff in, right? And at the end of the week, our kachra, goes out. But I know folks in Canada, you guys have, um, various different demarcations, uh, or the classifications, let's put it this way, uh, the dry kachra, the wet kachra, the khana, and whatever and whatnot, and so many of those, So, alhamdulillah, we do here in US, we do not have, that level of classification, we have to perform. It is good for the environment. Kudos to you guys in Canada. But yes, for us, it's just, two different types. We just, fill the kachra in. Uh, at times, I take the blame. At times, if one of my kachra bin is filled, I just, start filling in on the other one. I just make sure that lid is closed when the truck comes in. Otherwise, that guy starts making, the lanes, left, right, and center. Anyways, yes, Masood bhai. Masood, Sana, yes, and Anam, yes, glass and plastic and organic bins and garbage and all that. Yes, yeah. Alhamdulillah, you know, we do not have to worry about this. It's just, two things, let's just, put that in. The challenge comes in, during the bottom time, say if you had a majlis, or let's say, you have a big family party. and then the ketchup bin just fills up to the top. It's always a challenge. Anyways, it's always a challenge to classify this is the recycle or this is the the non-recycle ones. The top one is the clustering example. Say, you have a raw data. Raw data is, you see our raw data is here. We have, a couple of different types of, fruits here. I see some apples, some strawberries, and, you throw in some additional one, into the mix. The algorithm classify those, hey, like putting together, the strawberries in one batch, or classify them or cluster them in one batch, apples in different, and the other types in different types, right? So based on the specific types, we cluster those. That's the unsupervised learning because we did not provide any label to it. What we did is we provide the feature set is, this is something red in color, something, some two leaves it has, or, this is a green in color, or, or it has, some a different shape than this red one, right? So these are the feature set provided to it. And then based on those feature set, it distinguishes, hey, it is red. So it is red. It could be a red apple, or it could be a red strawberry. No, so the shape of a strawberry is different than the shape of apple. So let's just cluster together those, red strawberries together, so that's what it is, right? So, and this clustering could be combined with, say, classification or regression. Oh, let's say classification, right? So now we classify. So a hybrid example is non-labeled data, and we have some label provided to it. Hey, you know what? This is a thing that has some seeds on it, with a little bit of a heart shape, red in color. It's a strawberry. So we provide some label to it. So now it will label that cluster. This cluster is going to label it as as um, a set of strawberries, not a set of apples. Okay. Next one here. This is the I think I have two more slides left, and we're gonna finish at maybe in 10 more minutes. I know there's a session tonight, so yeah, so we're gonna be going into the session as well, and I should have Mubarak to you guys as well. This is the third week, right? So every week, every Friday we have a session. Today is Mala Boss's birthday, so yeah. So Mubarak to all of you, who are celebrating tonight. Okay, so coming to the ML decision tree. So this is a decision tree. It's not something that you have to worry about. It's just, I thought that this will give you some clarification. So we have on the left-hand side, you see here, you have supervised learning technique and you have unsupervised learning technique. On the sky blue color, the gray color, whatever the color you call it, on the top, you see the supervised learning technique, and the bottom, the yellow color, is the unsupervised learning. So question is, what are you trying to get from your data? What is the actual outcome I am looking for? Okay, I am looking for, I want to predict predict an outcome. Okay, do you want to predict a number or a category? If it is a number, is time an important part of your data or not? No, time is not important, then I'm gonna go here. The system suggested me to go with the regression algorithm. If the time is of importance, then it suggested me a time series regression model. Time series regression model examples, as the time progresses, that the the model progresses as well. Time series example is the weather forecasting system as an example. Okay. All right. tracking back, come back here. So this is the number specific, right? If I'm going with the number, either regression or the time series regression, right? The other one is if it is a category, if I have to categorize. Okay, so do you want to sort things out into two categories? If yes, like two categories, then it will be a binary classification. Binary classification, binary means two. Binary means, as an example, either 0 or 1, yes or no, or the two different types only. Okay, no more than that. The tracking back, no, I need more than two categories. Then it's a multi-class or multivariate classification. It could be like in our previous example, we were given three different types of fruits as an example. So that's the categorization. So if we are going with the categorization, the two algorithm, one is the binary, other one is the multi-class. Just remember those. Maybe this will help you out when to use regression, when to use binary, when to use multi-class. Okay. Now tracking back, coming down here, this one here. What do you want to do from the data? I want to uncover patterns and relationships. 1 second, let me make some clear here. Okay, so I want to uncover some patterns in relationship. Within your data, are you hoping to find a group with similar characteristics or common themes? If I am looking for a small group with similarities, yes, then clustering algorithm. If there's a theme in the return document, let's say you have PDF file or some Excel file, the problem could benefit from the topic modeling. If I'm going to create a recommendation system, then use the recommendation engine. If I am going to find the association between the items, then the association rule analysis. A recommendation example is a common example is Netflix, or YouTube as well, right? Netflix, like based on my preferences, what I'm watching, it will start, showing me preferences. Hey, you have watched this, you might be interested in this. You have watched this, you might be interested in this. So, that's the recommendation system. Okay. Next one. Um, Another one, to make your life easier. Hey, problem. What is that problem? Do I have a label that the data given to me, is it labeled or is it not? If the data is labeled, go with the supervised learning. If the data is unlabeled, go with the unsupervised learning. Remember? Under the supervised learning, category and quantity. Quantity is where, you have the numbers. Categories, not numbered, but, some sort of, categories given. And, these are, some of the algorithm examples. Same on the right-hand side, unsupervised learning. Is the data grouped or there's a lower dimension, right? So group clustering, lower dimension, a DRA or PC or LDA, those algorithms, can be used. I'm not going to drain this slide, but this is, for your understanding. Down the road, that will help you out. I have a reference where did I get this table from? This is the reference. This is the machine learning cheat sheet, datacamp.com. It's a very good website. It will give you more detailed information there. So you can download this cheat sheet. Hey, on the supervised learning, there is a linear model. What are those? There are, some algorithms. Remember, we looked into the regression and the logistics. Logistic is the output of 0 and 1. Linear, that, this table here or the chart. What are the applications? Applications, stock price prediction, housing pricing prediction, or some sort of, prediction in terms of the numbers. Logistic, credit card risk score or customer churn prediction. Credit card risk score. Hey, is he going to make it or not? Festival is going to make it or not. And there are, some advantages and disadvantages of this as well. Some other algorithm as well. Like I mentioned, I'm not gonna train this. It's a fundamentals, but better for learning and understanding for you guys. Okay. On the supervised learning side, there are, tree-based models as well. The previous one, they were, the time series or, 0 or 1, that type, Next one is the tree-based. Hey, like I said, Subha Ammi is asking, आज बिरयानी बनानी है या आलू गोश्त पकाना है या क्या पकाना है, आज मैं क्या पकाऊं? Those who are married, they get this question pretty much every day, every morning. आज क्या पकाना है, आज क्या पकाऊं, आज छुट्टी का दिन है, आज क्या पकाना है, so these are examples of tree based models. It could be a decision tree, random forest, decision tree है, बिरयानी पकानी है, अच्छा आलू देखना है या उसमें आलू है या गोश्त है, आलू नहीं है तो फिर क्या उसमें दूसरी सब्जी डाली जाए, अच्छा गोश्त है तो उसके अंदर बीफ है या उसके अंदर हमारे पास मटन है, एंड so keep going and going up to a point where you come up to a conclusion. That's the decision tree. Random forest, um, example of decision tree, but expand upon it, right? So there is one, let's tree, and say we have a similar decision tree, or similar of the same sort, going in parallel, and they are actually say attached with with one bigger root there. So random forest, that example. Credit score modeling, based off of say multiple areas to look into it. कि फैसल ने कितने क्रेडिट कार्ड खोले, फैसल की हिस्ट्री क्या है, फैसल का इनकम टू स्पेंडिंग रेशियो क्या है, फैसल के, और there's a lot of feature set that are going to be reviewed in that. And then there are a couple other not the advanced ones, but there are some additional ones. So if you just maybe hold on, let me do one thing here. 1 second. Come on. These two, decision tree, random forest, and maybe these two here, linear and logistic regression. Just go a little deep on this, learn more. You are good to go, to start taking on, the small to medium size, machine learning projects. Okay. Third one is the unsupervised learning. There are two different types, as mentioned. We did look into the clustering. There's another one is the association. Not gonna go in detail. Then, the algorithms. There are some, like k-mean or hierarchical or Gaussian mixture. Similar thing, some examples here, some, definition, around that as well. Okay. Linear regression, I thought to, give you guys, some details on that, but I'm gonna just leave it on the slide deck just for your learning, for understanding, if down the road, you want that. Okay. Here you see the, X and Y plane. Come on. X and Y plane. You see the X plane and then the Y plane. Y is the dependent variable. X is an independent variable. Example, let's say, you take an example, Y equals mx plus b. That's a very common linear regression equation. You might want to search for, y equals mx plus b. Yeah. So y is a dependent variable. Its value depends on x. There's a slope, and there is a other variable, other things of that nature, right? So this is the dotted line is the line of best fit. This is the 95% confidence band. This area here, these are the outliers. So this is the outlier which is deviated from the line of the best fit. Those data points. These data points is the value of x and the value of y. This is what the value is, and then there's r mean square or r square. So these are all the statistical terms. Okay. ML example in AWS. I know in our last class, I'm gonna go into the demo for you guys with the in the Azure side of the house. I will try to log into Azure ML Studio and try to look into those algorithms and things of that nature. But I thought, and I found some interesting material around the AWS machine learning. So these are three of the commonly used models there, classification models. And one of them is also in the bottom one. Two of the classification, the bottom one is the regression, the actual regression one, they use. And then there are, some examples, are here as well for each model. So this is the end of the class today. I'm gonna pause here. Let me stop recording, and I'm gonna open the floor for any questions